Hello, hello. Welcome to the third talk of the observability track of What the Fuck is SRE 2022. This event is brought to you by Container Solutions with our sponsors Blameless, Stormforge, Teleport, Cortex, Shoreline, Lightstep, PagerDuty, Fire Hydrant, and Rootly. Now let me do some housekeeping. We have a code of conduct. Please check that out on the Hopin, our event platform's landing page. We need you to follow our COC, and if you're seeing anyone around who's not playing nice, please let us know. There is a form on the Hopin main page. And so I'd like to hand it over to our lovely speaker, Philipp Krenn. And his talk is, why is it always DNS, TLS, and bad configs? I'm actually looking forward for this one. Hi, Philipp.
Thanks
how are you?
Hi, good. Let's see how this is going. And let's hope everything works, actually.
Yes, but yeah, we're I guess, used to it, right, as IT people.
Right. Yes.
Yeah, okay, go ahead.
Thanks a lot. Let me make that a little larger and let's go. So why is it always DNS, TLS, and bad configs? And while this is, I think, kind of like the official slide, the one that this should have, or what I always have in my mind is, if you still remember Harry Potter from ages ago, when Ron, Hermione, and Harry Potter get asked, like, why, when something happens, it's always the three of you. I always have in my mind that you have DNS, TLS, and config sitting there, and they're always causing those problems. And I'll play a bit on Harry Potter to some degree in this talk. But I think it's a nice comparison because there are some recurring things, and sometimes they're not even causing it, just like correlating. But there are still good signals to figure out when something is going wrong and you want to fix something. So DNS is maybe the most common cause of issues, or at least one of the very well-known one. Akamai recently had an outage where, well, it was unsurprisingly DNS, and I probably could make up 100 other examples here where something in the DNS config went wrong. Though I have my own perfect example here. Many years ago, when I was at another job, we were a small startup, we wanted to move DNS service, and I think our provider back in the days was called Gandhi, and we wanted to move to Route 53, which back then was pretty new, and I had to copy paste the DNS servers to the right place where we had registered the domain, so we could actually move over the DNS stuff. And I think we had a 24-hour timeout on the DNS entries configured, and I had to move 5 domains or something like that. And the first 3, I copied the right servers, but then I made a copy-paste error. And for the last 2, I copy-pasted the wrong DNS servers, and those DNS servers didn't know those domains. So over the next 24 hours, at first it looked like everything was working, and then in the middle of the night, you could see, excuse me, you could see that suddenly our DNS entries were dropping and were not reachable anymore. And the fun thing about DNS and the timeouts is that at first it looks like it's still working, and then suddenly it disappears. And also the fixes, potentially based on how long your timeout is set, can take a long time. Luckily, I did that, I think, on a Saturday or so. So we could fix it on Sunday, and then slowly Sunday night, the right entries reappeared again. But it was my personal lesson about how easy it is to screw up DNS, and also how tricky it is to figure it out, because for the first couple of hours, it looked like everything was fine. And then you can just helplessly watch as stuff disappears. So DNS is definitely one of those fun ones. TLS is also one of the recurring offenders that everybody keeps getting wrong. And I think my favorite example here is Microsoft and Azure, because they've had an ongoing situation, I feel like, with expiring TLS certificates or deleted TLS certificates. So this example here was, I think, from last year, where they deleted some certificates that they still needed. But there are quite a few more around Azure, like this one here, when everything on Azure dropped for some time, I think is from 2013. But they had their fair share of TLS mishaps where everything stopped basically because TLS was broken. And it's something that sounds stupidly simple because, well, keep the right certificates and rotate them in time. But it's devilishly tricky to get all of them and at the right point in time. So TLS is one of these other things that seem to lurk around to wait until you forget about it, and then it hits you. And finally, bad configurations are also one of these things that somewhere will catch up with you. My favorite recent example was the big Facebook outage where I think Instagram and WhatsApp and everything was affected. And it was DNS, but it also wasn't DNS because they had like how they announced the routes, and the routes, I think, to the DNS entries was dropped because they had a bad situation where, or a misconfiguration there. And then everything stopped, and it was this well-known incident, I think, where everything was built around DNS and that DNS is available for them, and they couldn't even enter the data center. And I think there are great stories about them having to hack through some doors or whatever to get access and physically fix something on site there, because without DNS, everything was broken and toast. But the underlying issue was not actually DNS in that case, but a bad configuration. And it's often a combination of bad configuration and something else going wrong, and then everything fails. So maybe this is like what in Harry Potter would have been called a Horcrux. Or these three might be three of those Horcruxes that we tend to fight or need to find and not destroy, but fix in IT. So what is the solution to our Horcruxes? And while in Harry Potter, I think it's very much like fight fire with fire. That's not necessarily how we do it in IT. But my theory or thought here is that to fight those Horcruxes in IT, we basically want to use some health checks, which is, if you look at observability, where it's always about logs, metrics, and traces, it's not really part of that. And probably it's more on the monitoring side, where you actively check something to figure out, is it really working? And you have a dashboard for that. But it is still a very useful tool. So since these happen so frequently, if you structure your health checks correctly, you can still very quickly see what goes wrong or if something goes wrong, without having to step through a lot of logs to see like, something weird is failing here. What could it be? So to take a bit more of a proactive approach with health checks. And my kind of like mental model is basically that you want to have a structure of health checks on three different levels. So you have, let's say you're hosted on AWS, is your cloud provider, and your services are in one or multiple availability zones. And then you want to have like a check from a different provider, like, I don't know, something cheap like DigitalOcean maybe, that just pings your service to see how does it look from the outside, from a different DNS server. What's kind of like the view from your users from the outside. Then you might want to have like a check from a different availability zone in the same region from the same cloud provider, just to see like, is it a problem between availability zones, for example? And then you might want to have a check actually on the host itself to see, is it the host or is it the network around it or something else? So with these like three different layers, you can hopefully figure out where your things should be kind of like connected and where it's failing. So looking at it from a different provider, you can see then, okay, DNS is not being resolved to the right provider or is not working. That is a problem that you can easily kind of like find before your users hopefully run into it. Have you misconfigured the outside firewall for your service and suddenly block some legitimate traffic? Hopefully you can catch that with a health check as well. Is your load balancer down? So your health checks inside might work just fine on the service, but it's actually not reachable because your load balancer is down or forwarding to the wrong address. Is the outside network connection from your cloud provider broken? Is your service generally up and is TLS broken? So from this outside view, it's kind of like closest to the user. And you can then hopefully see like more from the user's perspective. And then comparing that to what you see on the inside, you hopefully figure out relatively quickly what is actually the problem. Like the service is actually up inside my cloud provider, but not reachable from the outside. suddenly you have a much clearer picture of like, where should I start looking? Is it DNS? Did I apply a bad firewall rule? Is the load balancer down? You suddenly have a much smaller surface of things you need to check when you see like, okay, from a different availability zone, it's still working. If that goes against the load balancer, then you know, okay, the load balancer is probably fine. Then it's maybe the firewall or DNS or maybe TLS expired. But you have a much better picture of kind of like where you start looking and diving into. If you have a different availability zone to run the checks, you can still check like within the cloud provider, are the DNS lookups working correctly? Because you might, or you probably rely on those. Is the inside network within the availability or between the availability zones within the region of the cloud provider working? Is the service generally reachable, or did you mess up some internal firewall rule again? And it can also be very helpful to, for example, compare the latency from your service within the cloud provider to the outside to further dive into potential networking issues that inside your network look fine, but on the outside, it's actually not fine for your users. And then if you're pinging on the same host, or at least something very close to the host, you can then see, is my service really available? If you have something like, for example, a reverse proxy on the server running, like Nginx to terminate TLS, for example, if you have like more of a classic setup, you could then figure out like, oh, the service is actually running on the host, but its proxy is down. That's why it's not reachable. And you know exactly where to start looking or what to restart. You can also from the host itself then check like, oh, the database that is running on another host, like, oh, I cannot access that. And then you can hopefully figure out the database is down. You apply the bad firewall rule again. Something is wonky on the network. And again, you can compare the latency from this service to other, like the other two pingers that you had. And then it hopefully gives you a better impression of where is a lot of the latency coming from and what is actually slow. And all of this combined, like structuring it the right way, hopefully gives you a much better insight into what is causing the problem. And you can pinpoint and start then debugging with your other tools where to fix stuff. So why have I been talking about all of this? Obviously, we have a solution for that. And I just quickly want to mention it. There are lots of tools for pinging. We have some that will do that job, but anything that does pinging will probably be just fine. This is just an example to show you how this could look like. So here I have set something up where I have 32 so-called monitors, where I'm pinging my service and then whatever domain I have. I think the three types of pings that you generally want to have is like, you want to have an ICMP ping to see like, oh, can I even reach the host? You want to have a TCP ping for something like a relational database like MySQL or Postgres that doesn't speak HTTP to see like, can I reach those? And then you want to have an HTTP ping to see is that service available? And with that HTTP ping, you probably can do HTTPS checks as well. For example, for us, it would look something like this, where it tells me, okay, these are all the certificates that are available, and when do they expire, or when did you create them, and from where? And with that, hopefully all your TLS problems are gone. Finally, you might want to do some more in-depth check on your service, where you say like, oh, we actually do a post and then simulate a bit more what the user is doing to be able to figure out if higher level functionality is working. But that's almost a step beyond health checks already. And then I think the new hotness is synthetics, where you run or pretend to be a user, run through some common steps to actually figure out from your health checks that something is broken before your users run into that. So to wrap up, health checks are I would say, cheap, fast, and easy way to get an overview. Obviously, it depends on how useful they are and how you need to structure them for your service. But you don't need to keep terabytes of data around. You basically just need to have the check and compare it to recent data in terms of latency and what is available and what is not available. But they can, if they are structured the right way, help pinpoint very clearly where something might be broken to find your so-called horcruxes. And with that, we're done. I hope you don't fail for DNS, TLS, and bad configs in the future. And this kind of gave you the right thought where to go from here.
Awesome. Thank you so much, Philipp. That was a really insightful presentation. And I have to admit, I'm a huge Harry Potter fan. So when I saw your presentation come through the program committee, I was like, oh, that's a Harry Potter one. We don't have too many questions in the Q&A side, but I do have a question that's just come through on the live chat. So how would these methods have prevented the Facebook outage? You know, some ideas or things that they could have maybe looked at doing better?
I mean, I guess I think Facebook is a special one because their infrastructure is very different to the average infrastructure. So I'm a bit cautious to say like, oh, from my armchair, I will tell Facebook how to monitor their outage. I think what I've tried to present here will more apply to like your own service, which doesn't have a million users, because Facebook will very quickly realize that. But I think the underlying issue with Facebook was that the BGP routes that they were announcing were suddenly not resolving DNS. So with that health check, you would find it very quickly. On the other hand, Facebook probably has 100 SRE engineers or 1,000 on call right now. So I assume they found the problem pretty quickly. Just resolving it was much harder. I'm kind of careful to see, like Facebook would have fixed this with health checks. I think like the average 80% service will probably gain more from that than Facebook.
Agreed. And so tell me a bit more about the synthetic monitors. You know, what are their advantages over standard, just like, you know, normal ping checks or similar?
Right. So you would commonly just have like a regular like flow, like I don't know, you have an e-commerce shop and you put something in the cart and you do the checkout, and you basically every 5 minutes or whatever you run through that. So you figure out very quickly if something is broken in that very common flow, and then you can fix that before your end users are actually being affected by that. So it's, I think, more from it's trying to take more of a business view, like what is important from a business perspective, because health checks are often very technical. It's like, oh, what is the latency on the database? And maybe your end user doesn't care so much. It's like, it's a decent signal to have, but your end user doesn't really care about that. But synthetics are really more about like, oh, I want to find this before the end user suffers or has problems. So we can hopefully figure that out. And then because it's automated, it can just run continuously. And hopefully you're quicker than your end users, or you just have that running on a staging server and then roll back the deployment. It could also play into testing as well, the synthetics. But of course, it's because you normally need to simulate a browser, it's much heavier to run. And it's a bit of a heavier tool. Also, it might be more dependent on your UI because you probably simulate some clicks. So it might break more easily. But it's like higher value, but also higher cost, I want to say. But it's a fancy topic. Like I think lots of companies, including us, are building their own synthetics right now and give them various names. But you will run into it one way or another.
Awesome. Thank you so much. I do have one last question for you, and then I'll let you run away, Philip. What parameters should you look at when choosing synthetic monitoring tools, and some recommendations?
Yeah, so I think the automation is almost standardized, that there are a couple of JavaScript libraries that do the simulation. So even though it's cleverly wrapped by various vendors, you will come back to the same 2 or 3 libraries under the hood. And then I think it's really more about the way, like, how do you collect the data and how can you visualize what is going on, and what features does it add there? For example, do you have like the latency of every single step? Do you have the latency in like loading the page and find regressions easily? So I think it's like you need to find like a reasonable amount of like features, because while you could have 1,000 features, if nobody looks at it, it's no good. And I think that's kind of like the advantage of health checks, that they're very simple and you can have a very simple alert. Whereas synthetics are more complex to debug, or could have easier, or could have more regressions in them. But I think you need to find something that finds your pain point. So if you're concerned about latency, make sure you have a tool that is good at visualizing that and finding those. If you're just concerned about the correctness of the flow, probably a different one. Others are very concerned about like the resource usage of running that, because they're running so many checks in parallel. If you only run one flow every 5 minutes, maybe not such a big deal. If you run 100 every minute, it might be a very different story. I hope
Awesome.
that is the very short answer.
Perfect. Thank you so much. I'll drop a couple, if you could drop a couple of social links that I can share with our audience, if they can come find you and reach out. I'm sure a good few people would love to have another chat.